oxidizing agent, strong oxidizing agent.
Yeah, a strong, would you say moderately strong or very strong? A very strong oxidizing agent. In fact, that that number, remember the flammability rating on dichromate? What was the flammability rating? 0. Does that sound right to you? It doesn't sound right because dichromate is extremely reactive. Now, permanganate is another very powerful oxidizing agent. But when we have something like this, a potential diagram that came from the first week, we can see permanganate can go to different products depending on what kind of reducing agent you react it with. So for example, if you take permanganate and react it with a very weak reducing agent, it doesn't go very far. With a very weak reducing agent, it might only go to MnO4 2-, or it might go to MnO2, but it might not go all the way to Mn2+. In our redox chart, we have permanganate going to Mn2+, and we're ignoring all these other potential products. And so in some reactions, what we have, depending on how strong of an oxidizer we react it with, it varies. So for example, ethanol. What do you know about ethanol? Ethanol is not on the redox chart, but what do you know about ethanol by analyzing its structure, like we did in class? Is ethanol electron rich or electron poor? Electron rich. Ethanol is electron rich. Are oxidizers electron rich or reducers electron rich? Reducers. And one way, even though dichromate didn't get a very high flammability rating, ethanol would get a very high flammability rating, right? Because ethanol is highly flammable. And what makes a good reducer? Good reducers are electron rich. Did you know metals? Did I mention that metals are also flammable? Did I mention like steel wool or powdered metals will have a flammability rating on there? And so basically this. Some people put chloride as a reducing agent. Let's say, I ran out of wood for my fire. What would you rather get to build a fire? Would you rather grab a bottle of ethanol or would you rather grab a bottle of sodium chloride? Which one do you think is going to burn more easily? Ethanol. Or would you rather grab a lithium battery to build a fire, or would you rather grab something else? Lithium, right? Lithium is a very powerful reducer. It's electron rich. And so the first thing you should recognize is that ethanol is going to be, even though it's not on the chart, ethanol is going to be the most powerful reducer on there based on experience, based on your experience with alcohols, perhaps. All right, the next thing is this. Ethanol depends on what you react it with. Did I tell you about the wine I bought in Joshua Tree? No? I went camping in Joshua Tree, and we went, I think it was Big Lots or 99-cent store or something like that. They had 99-cent bottle of Santa Barbara wine. So I thought, wow, Santa Barbara wine, 99 cents, I'm going to buy it. And so brought it back to the campfire, and took one sip, and it was vinegar. It wasn't wine. And what had happened is a little bit of oxygen leaked in there and partially oxidized the ethanol. That partial oxidation is if we have a mild oxidizing agent. This is a symbol for oxidizer here. And so if we just do mild oxidizing conditions, we do mild oxidizing conditions, and now some of you put this. Some of you put, we could oxidize this to this. This is acetaldehyde. And so this is one potential. So if we mildly oxidize it, we go to acetaldehyde. If we oxidize it a little bit more, we could go to acetic acid. And so a lot of people put acetic acid, right? And so that's like what happened to the wine. What happened to the wine was, a little bit of oxygen leaked in. But if we compare a little bit of oxygen to 1 molar dichromate, what do you think? Is there a huge difference in oxidizing power? Yeah, there's an enormous difference. Dichromate is much stronger. And so maybe dichromate will oxidize this all the way to soot, right? Do you think, or do you think it'll go beyond? And so you think, does ethanol burn? Yes, it burns. Does ethanol just burn, when it burns in oxygen, does it just burn to soot? So if I combust ethanol, it just goes to black soot. We get a whole bunch of black smoke. No? Oh, then it must go to carbon monoxide. It goes to carbon monoxide, so if you burn ethanol, you better not breathe any of the fumes off there because you can kill yourself with carbon monoxide. Does it burn to carbon monoxide? No? Well, maybe it gets oxidized more. If it gets oxidized more, maybe it goes to carbon dioxide. If we go to carbon dioxide, well, you know what? Dichromate is so powerful, I expect it to go to at least carbon trioxide or carbon tetroxide. What do you think? Would it go to carbon trioxide or carbon tetroxide? No, because those don't exist, so we're going to stop here. We're going to go to the max because dichromate is even more powerful than oxygen. Oxygen can easily burn ethanol to CO2, so why can't dichromate do the same thing? Why does dichromate have to stop at acetaldehyde or acetic acid, vinegar? It just doesn't make sense. And so this is part of, just building the basic knowledge in chemistry a bit. And so this is why I gave this particular reaction for this particular lab, the synthesis lab. Okay? And this just shows, partial reduction going to the right or partial oxidation going to the left here. And we see this in the homework. If you go to homework problem number 23, I think, in chapter 15, you'll see, when we burn nitrogen, have you ever burnt nitrogen? If you drove your car today, you burnt nitrogen. You burnt nitrogen in the combustion chamber. We need huge pressures and huge temperatures to burn nitrogen. When you burn nitrogen, we'd like to take it all the way to that. But it's so hard to burn this stuff because this stuff is such a bad reducing agent, we end up forming NOx. NOx is partial combustion. We might form N2O, we might form NO, we might form NO2, etc. We're going to get a mix of products because this is a very bad reducing agent. However, this is an awesome reducing agent. So it makes a huge difference. This we expect multiple products, and that's why we call it NOx, because we're going to get a mixture of products in this. For sure we're going to get a mixture. I don't think we can burn it all the way because it doesn't burn. How hard is it to burn nitrogen? Extremely hard to burn nitrogen. But you can do it in the combustion chamber of an automobile. Okay? All right, let's stop here. Let's take a short break, and then if you're ready to start, I'll pass it out to you.
I'll make sure it's needed.